Hello everyone, I am Hassan, and in this presentation I will be talking about the project that we have done for the course data communication networking in fall of 2021. So for this project what we designed is basically an enterprise network for the airport, where we looked at the specifically at the SCADA systems which are employed within the airport. So in this presentation I will be firstly going through the final research report that we produce for this study, and then we will move towards the working of the simulation that we perform for this project, right? So our project was basically to look at the network that are employed within the within the domain of cyber physical system, where the networking has to be integrated into the physical machinery or sensors or actuators, um, to basically ensure their proper functionality and timely operations. So we conducted this study in the context of airports, where we specifically looked at the SCADA systems or supervisory control and data acquisition systems, where the where the machines are interacting with each other and sensors are sending data and receiving data in real time, right? So we specifically looked at in the context of the airport. So first of all, we conducted our initial surveys as to look the currently employed infrastructure of the airport within the network, where we found the vulnerable potentialities that may allow some sort of attack to take place, such as DOS or DDoS attacks within the airport. Uh, and also one of the most commonly occurring attack is basically a Stuxnet attack, which usually occurs within the SCADA systems, right? So we looked at the existing infrastructure for the networking airport, for the networking that is employed in the airport, and the configuration of such a network, of such an enterprise network. Then we looked at the current existing framework for the enterprise network, specifically in cyber physical systems, where we looked how the sensors are connected with the controllers and how they are connected with the cloud services and servers, in order to ensure the timely receiving and sending of information between the devices, between the sensors, and between specific entities, right? Once we have surveyed the framework for the existing infrastructure of the airport, next we studied the potential attacks or the privacy taxonomy for these airport, where we identified couple of airports such as the one I mentioned before, including DOS and DDoS. And apart from that, we also looked at the Stuxnet um, worm, which is basically which is usually found within the SCADA system. And one of the example for this for where it was deployed was basically in Iranian uranium enrichment plant back in, I believe, was, I think, 2016 or something, but I'm not sure about that, where it reportedly damaged about 1,000 centrifuges of the Iranian um, enrichment plant, for which are basically used to enrich the uranium. Although this system, as we conducted our survey, we found out that although this system was extremely secure, but this worm like Stuxnet basically infiltrated the machinery without letting the host acknowledge it anyhow, and it can easily be transferred from one machine to another with a simple plug and play of USB or any such device, right? So even if the network is isolated, for example it's a LAN network, which is not exactly connected to the outside world, it can still infiltrate such a network, right? Then these attacks usually takes place at layer level. So we have, as this figure 2 right here shows, that it can either occur due to the human operator, such as exchange of information using hard disks or devices such as USB or SSDs or other devices like that, or it can occur at the at different layers using the um, using these worms and viruses, or flooding or denial of services and other such potential harm that can be caused in these systems, right? So once we have explored the privacy taxonomy for the airport systems, next we move towards the SCADA systems that are currently employed in airport, where we looked at how the complete infrastructure of the airport is interconnected with each other and can easily and is very vulnerable to attacks, to which can basically disturb the flight operations, including the database management for the passengers, flight schedules, and timely operations of those flights. Then we conducted a brief survey for the identified attacks so far, where we touched upon some of the numbers within that. So once we have conducted the survey for the attacks that have been identified so far in the context of the airport, we next try to implement such an attack within one of the simulation tool. But that the work wasn't completed. So in this project report, on the research report, we haven't exactly reported that work, but this project does have the future potential to for such an simulation to be carried out, right? So the rest of the research report talks about the simulation framework that we constructed for this project, and what were the security features that we had implemented for this project. So I will attach a link of this research report with this video, and apart from that I will also include this final report, which includes all the configuration of all the two of the components that we perform within the simulation tool. The simulation tool that we used was for packet tracer. So this report includes all the configuration tools for each of the device that we use within our simulation. Right, so now I will talk briefly about the simulation itself that we created. So what you're seeing on the screen is basically the airport enterprise network that we designed, in which we constructed a total of three networks. The first one was the airport authority network, which had absolute control over all the networks, including the guest zone, which is the other network, and the flight service provider, which is another network. So there are a total of three networks, right? So within the airport authority network, as you can see, we have the different devices which are interconnected with each other using the wired communication as well as wireless communication, and each of these devices are assigned an IP address using DHCP server dynamically, which is within the airport authority network as well. And apart from that, it also contains specific servers such as SMTP, HTTP, DNS, FTP, and flight database itself, which would be accessed by flight service provider on the right. So and this airport authority network is interconnected with the other two network of gas zone, or the passenger network, and the other one is a flight service provider. So as far as the passenger or the gas zone goes, it should only be able to connect to the internet and explore and browse the internet, and apart from that, it should not have access to any other of these servers within the airport authority, including the flight database, right? So we configured these settings using ACL on this router right here. We also use multi switches, but the ACL configuration or access control list configuration were performed on these routers right here, which allowed these devices to be only connected to the internet, and not able to any access database of the airport authority network, right? And apart from this last network that you are seeing on the screen is flight service provider, which basically have access to this flight database server right here, only and only this one, so that it can manipulate the flight schedules as per the requirement. And apart from that, we also implemented the VLANs for these two networks, but it was later removed because it wasn't reasonable for these two networks of gas zone or flight service provider to be communicating with each other. So that was to only basically implement the functionality of the VLANs, right? So as for firewall, we used ACL upon this router, and which all allows the two networks right here, gas zone and flight service provider, to access only specific servers within our airport authority network. And apart from that, no attack was such as DOS and DDoS was simulated within this simulation, but it does have potential for such an attack to be simulated, which might be conducted in the future if we extend on this project. But so far, this is a work done right, so I will also attach the file for this packet tracer simulation with this video, and so that if someone wants to modify it or implement it by themselves, they can do it. Right, so I think this concludes the presentation as far as this project goes, and if I do make some changes to the simulation or implement some attacks such as DOS and DDoS, so I will upload a update video. Right, so thank you for watching, and Khuda Hafiz.